A number of you seem to be having difficulty with the last question on the homework for Lesson 5 related to the measures of spread. So I've pulled up one of those questions. There's different versions. So this is one of them. And it reads, a study studied the birth weights of 1,854 babies born in the United States. The mean weight was 3,234 grams with a standard deviation of 871 grams. Assume that the birth weight data are approximately bell-shaped. Estimate the number of newborns who weighed between 1,492 grams and 4,976 grams. Write only a number as your answer and round your answer to the nearest whole number. And there's a couple of things that are important to think about as you're reading through this problem. One is it is approximately bell-shaped. Okay, and so the fact that it is approximately bell-shaped is a clue that I can use the empirical rule to estimate the number of newborns. Okay, if it were not bell-shaped, you would have to use Chebyshev's. So we're going to employ the empirical rule here. And if you'll remember, the empirical rule says that there is approximately 68% of the data within one standard deviation of the mean. There is approximately 95% within two standard deviations of the mean, and 99.7% within three standard deviations. So that essentially all the values of your data should be within three standard deviations of the mean. And so we also know what the mean is. They tell us in the story what the mean is. It tells us that the mean weight is 3,234 grams. They also tell us the standard deviation is 871 grams. So if you want to picture this, it tells us that we have an approximately bell-shaped distribution. So I'm going to kind of draw me a bell-shaped distribution here. It tells me that my mean, which is a measure of center and would be in the middle, is 3,234. I'm told that the standard deviation is 871. And that we want to know what percentage of babies, or ultimately the number of babies, are between 1,492 and 4,976. So we're looking for, let me change colors here. I'm looking for that percentage between these two numbers. Okay. The empirical rule is going to give me a percentage, and then I can use the percentage that I find to determine the number or estimate the number of babies. And so what I need to do is figure out how far away from the center, from the mean, is 1492 or 496. Is it one standard deviation, two standard deviations, or three standard deviations from the mean, or is it some, weird value? So we ultimately need to figure the z-score, which is that measures the number of standard deviations. So we take the mean, or excuse me, not the mean, we take the x value that we're given. Okay, so we take the x value that we're given minus the mean divided by the standard deviation. And so I'm going to do that for both the lower limit and the upper limit. So if I calculate the z-score, or the number of standard deviations the value is from the mean, I would have, oops, sorry about that. Let's see if I can get that. Okay, so I would have z equals 1492 minus 3234 all over the standard deviation of 871. Now, you want to do the subtraction in the numerator first. That could be one of your issues. 1492 minus 3234 gives me negative 1742 over 871. And then I perform the division, and that gives me a value of negative 2. So I know that 1492 is negative 2 standard deviations below the mean. Then I'm going to go back and calculate it for the upper limit. The upper limit, I would have z equals 4,976 minus 3234 all over the standard deviation of 871. Again, perform the subtraction in the numerator first. So 4976 minus 3234 is, in this case, positive 1,742 divided by the standard deviation of 871, which gives me 2. So basically here we're looking at, we're 2 standard deviations below, 2 standard deviations above, and according to the empirical rule, we know that 95% of our data values fall within that range. Well, if I go back to the story and look, in the story, they tell me that there were 1,854 babies born in the United States in this particular study. So I really need to know not 95% of that, because we're saying that 95% of the data values fall between those two values of 1492 and 4976. So we're going to multiply 95%, write it as a decimal, which is 0.95, times the number of babies, 1,854. Okay, do the calculation. 1,854 times 0.95. It comes out to be 1,761.3. You're asked to round to the nearest whole number. When you round that value to the nearest whole number, you get 1,761. So we could estimate that approximately 1,761 babies that were born in the United States in this study were between 1,492 grams and 4,976 grams.